Hello everyone, welcome back to our channel. Let's discuss the next name reaction, that is Demjanov rearrangement. So this reaction is also an example of rearrangement reaction. Let's see the statement. The reaction of primary amines with nitrous acid gives rearranged alcohols. So here the reactants are primary amines, the products are alcohols. The reagent is nitrous acid. See the equation. This is the primary amine. If you consider this is a R group, RNH2 is the primary amine. This primary amine is going to treated with nitrous acid, means HNO2, to produce the alcohols. The first product is the replacement of NH2 with OH. The second product is the rearranged one. The 4-membered cyclic ring is converted into 5-membered ring with OH group. Okay, let's see the mechanism. Initially what happened? We have nitrous acid or not. So 2 moles of nitrous acid is going to treated with each other in acidic media. So what is happening? One molecule of the nitrous acid in which oxygen containing lone pair of electrons donates its lone pairs towards the H+, thereby 1 mole is converted into OH2 plus NO, another mole is normal one. The normal one is going to treated with this one. How it is happening? This OH bond is cleavage, create the pi bond here. Here the pi bond is converted into single bond. The oxygen will take minus charge. The minus charge will approach this nitrogen. Thereby these bonding electrons moving towards H. Oxygen. Thereby H2O will be removed and here H plus will be removed. So you will come up with O double bond N, O double bond N, oxygen, oxygen, N double bond O, N double. This will be treated with our primary amine. So in case of amine, nitrogen containing lone pair electron or not. This lone pair electron donated to the nitrogen, thereby these single bonding electrons move towards the oxygen. Oxygen will take the minus charge, right? Here nitrogen is donating electrons, means we will come up with NH2 plus or not. In order to neutralize the positive charge on the nitrogen, we can remove the H as H plus. Thereby that H plus and this O minus will remove in the form of OHNO. That is HNO2 is removed. Now N single bond and double bond O. Here transfer of hydrogen takes place from the nitrogen to oxygen. Thereby the N single bond N converted into N double bond N, NO double bond converted into NO single bond. In solution we are having H plus ions, that's why oxygen donates its lone pair electron towards the H plus, thereby it can be converted into OH2 plus. To neutralize the positive charge on the oxygen, these single bonding electrons move towards the oxygen, thereby H2O will be removed. We will come up with positive charge here. That's why these lone pair of electrons donating towards this one can form a pi bond. By formation of the triple bond, we will come up with the positive charge. Okay. Now what happened? The extension of the ring takes place. Here this bond is subjected to cleavage. For your convenience I am saying, if you cleave this bond, the minus charge will be here, the plus charge will be here. The minus will attack here. This minus charge forming a bond with this one, thereby nitrogen will be removed in the form of N2. So see 1, 2, 3, 4 and 5. 5-member ring will be there and here positive charge will be there. Now water is attacking here, you will come up with OH2 plus. To neutralize the oxygen, H plus will be removed and the final product will be OH. Okay. For getting the similar kind of alcohol, here the same moiety we have taken. See this one. Okay. Here N is removed in the form of N2. Thereby positive charge is created here. Oxygen donated its lone pair electrons to this positive charge. Thereby we will come up with OH2 plus. To neutralize the oxygen, these bonding electrons moving towards oxygen, thereby hydrogen removed in the form of H plus, and we will come up with the same replacement of NH2 with OH. Okay, thereby we are getting these kind of products. Okay, let's see some applications. Here what we are observing. Generally what needs to be done? the NH2 should be replaced with OH, right? But here we are not observing that OH. Here the NH2 is replaced with pH and OH is attached here. Why the situation is happened? Because see this one. Here the intermediate is this one or not? That NH2 is converted into N triple bond N plus or not? See. That NH2 is converted into N triple bond N plus. So here N is removed in the form of N2. Thereby we are coming up with CH2 plus or not. So this is 1 degree carbocation or not. So in generally in most of the cases, whenever we have a carbocation rearrangement, it is necessary that we need to identify the possibility that can we convert the formed carbocation into the higher degree carbocation or not. If we have a chance, we need to do that. In this rearrangement, we are observing that kind of phenomena. See this? This is CH2 plus. If you migrate this pH to this CH2, thereby you will create positive charge at this carbon or not. Now see this 1, 2, 3. 3 bond means this is tertiary carbocation or not. Already we know that tertiary carbocations are highly stable than the primary carbocations or not. It means here there is a possibility for the higher degree carbocation formation. That's why we have done that procedure here. Now H2 is attached here, thereby we will come up with OH. So this kind of common sense you need to play while doing the applications of these kind of rearrangement. In most of the cases in rearrangement reactions, we will face these kind of situations. Whenever we observe these kind of situations, we should be very attentive. In most of the entrance examinations now, they will give these kind of questions only. Okay. In the next step, what happens? Hydrogen from here, OH from here removed in the form of H2O, and we will come up with this one as a minor product. Okay, one more application we have here. This is exo-endo. This is the exo compound. This one is endo compound. Exo compound is subjected to Demjanov rearrangement. Simply the NH2 is replaced with OH. In case of the endo, what happened? The extended version takes place. Here the 4-membered ring is converted into 5-membered ring is not. In this case also similar situation happened. Here this bond is subject to cleavage. Here N triple bond N plus will be there, and these bonding electrons forming like this. Thereby the 6-membered ring is converted into 7-membered ring. Rearranged alcohol is observed. Here also similar kind of situations. The 6-membered ring is converted into 7-membered ring. Always try to remember in your mind that in case of carbocation, carbene ion or free radical rearrangement, if there is a possibility for the higher degree carbocation, especially in case of carbocation and the free radical, do that. In case of anion, the stability order is reverse or not. So based on the stability you need to follow. Okay, so this is the Demjanov rearrangement. Here we have small extension of the Demjanov that was given by the Tiffeneau. That's why that is commonly called as Tiffeneau-Demjanov rearrangement. What is the name? Tiffeneau-Demjanov rearrangement. In the Demjanov rearrangement, what we have taken? Primary amines or not? Right? This is the example which we have taken or not? NH2. Okay. In the Tiffeneau, what happens with respect to nitrogen? This is alpha carbon, this one is beta carbon. If you keep OH, then we will come up with carbonyl compound. Then what is the name of this compound? Is it correct? Can I say like this? Alpha, beta? For your understanding purpose only, I am saying like this. Whenever OH and NH2 will be there, always oxygen is treated as the main functional group. This one will be the substituent. If this is the situation, according to the OH, we need to give the designations. So according to OH, this one is alpha, this one is beta. So now the name is beta amino alcohol. This is the real name, original name. Okay. For your blind understanding what I am saying, in the Demjanov we have taken NH2. At the beta position put the OH. Okay. Simply remember like this only. But the real name is beta amino alcohol. Okay. See this. Beta amino alcohol converted into carbonyl compounds under the same conditions. What are the same conditions which we have taken? HN. Sometimes what happens in the examination, people will give like this: NaNO2 plus HCl. It can generate HNO2. This is very, very important. Okay, don't get confused. So similar situation, the same mechanism will take place. In this NH2 will be converted into what? N triple bond N plus or not? See this. N triple bond N plus is there. Now what happens? Whatever the ring we have, the cleavage of bond takes place. This is minus, this is plus. The minus will approach here, N2 will be removed. So the 6-membered ring is converted into 7-membered, and here we are getting positive charge. See this OH positive charge. To neutralize this carbon, what we are doing? We are removing H plus. So we will come up with a ketone. Okay. So this is very, very important observation which we have. Generally what we are observing, this kind of rearrangements in the cyclic beta amino alcohols. This is the cyclic one or not? Generally Demjanov rearrangement is observed in the cyclic compounds only. Okay. So this is all about Demjanov rearrangement and Tiffeneau Demjanov rearrangement. Okay. Thank you.